Hi, welcome to Namis Academy. This time we'll be dealing with trigonometric identities. Yes, trigonometric identities. This is our fourth series. This is series number 4, trigonometric identity. Trigonometric. So this is series number 4. Series number 4. So what are we going to do in this series? So we are going to prove. We are going to prove that 1 minus sine theta in bracket multiply by 1 plus sine theta divide by sine squared theta is equal to cot squared theta. I know seeing this you're already thinking, what am I going to do? But it's as simple as this. Let's get into the solution together. So as usual, for us to make the left hand side of the equation to be equal to the right hand side, we would need to take one of the side to make it look exactly like the other side. So in this video, we're going to take the left hand side of the equation to make it look exactly like what we have at the right hand side. So this is our left hand side, of course, on your screen. This is your right hand side. So we're going to take this equation and then simplify it until we have cot squared theta, yet following the rule of trigonometry. So let's take the left hand side. The left hand side. The left hand side of the equation says 1 minus sine theta multiplied by 1 plus sine theta all over sine squared theta. So what we need to do first is to remove those brackets. So remove this bracket by expanding what we have here. So that will be 1 multiplied by 1, then we have 1 multiplied by plus sine theta, that should be plus sine theta. Now minus sine theta multiplied by 1 will be minus sine theta. Then minus sine theta multiplied by plus sine theta. Minus times minus will definitely give us minus sine. And then sine theta multiplied by sine theta will give us sine squared theta. So all divide by sine squared theta. So looking at it, I have plus sine theta minus sine theta. Mind you, this is minus sine squared theta. So I cannot say minus sine squared theta cancel plus sine theta. Instead, I can just say plus sine theta cancel minus sine theta because they have the same value. But one is negative, the other one is positive. So I can just say plus sine theta minus sine theta is 0. So I'll have 1, I'll have what's left, I'll have 1 minus sine squared theta divided by sine squared theta. So what next am I going to do here? You will need to recall that sine squared theta, you need to recall that sine squared theta plus cos squared theta is equal to 1. This is proven using Pythagoras theorem. And if you have watched our series 1, you would have seen the proof of sine squared theta plus cos squared theta equal to 1. So we will now have to substitute the value of 1, which is sine squared theta plus cos squared theta, into what we have left by the equation of the left hand side. So let's get to the next page. What we have left was 1 minus sine squared theta all over sine squared theta. So by the time we substitute the value of 1, it becomes sine squared theta plus cos squared theta minus sine squared theta all over sine squared theta. So I have sine squared theta minus sine squared theta. So this is definitely plus because there is no negative sign before it, so that means it's positive. So if it is positive, then they have equal value, sine squared theta and sine squared theta, but this is having minus, so I can say plus minus this is 0. So I will be left with cos squared theta all over sine squared theta, cos squared theta all over sine squared theta. Our aim is to make it look like cot squared theta. So what idea is this giving us? You should recall quickly that tan theta is equals to sine theta all over cos theta, so as tan squared theta would be sine squared theta all over cos squared theta. If that is the case, we can see that the inverse is what we have here. If that is the case, the inverse is what we have here. Cos, which is supposed to be the numerator here, is now the denominator here, and the sine, which is denominator here, is now numerator here. That tells that what we have is an inverse of tan. 1 all over tan squared theta is equal to cos squared theta all over sine squared theta. That is exactly what we have here. Cos squared theta all over sine squared theta. So that's what we have here. So we need to recall too that 1 all over tan theta is equal to cot theta. If that is the case, 1 all over theta is equal to cot squared theta, and that is 1 all over tan squared theta, which is equals to cos squared theta all over sine squared theta is cot squared theta. So we just made the left hand side now to be equal to the right hand side, because this was what we got as the left hand side to be equal to what we have at the right hand side. So we have seamlessly proven that, say that 1 sine theta multiplied 1 by 1 plus sine theta divided by sine squared theta is equal to cot squared theta. So you can see how simple we're able to convert it to look exactly like this, because this gives us cos squared theta all over sine squared theta, which is equal to cot squared theta. I believe you understood everything we did in this video. Bye bye. See you in the next video.